Good afternoon, dear students. On our previous lesson, we were investigating functions for continuity, and our topic for today is derivative of function. Uh, so so first of all, before we start, let me uh, remind you some theoretical information that will be useful for us. So arithmetic properties of derivatives, so that we can move the constant out of derivative. Derivative of the sum equals sum of derivatives. Uh, so how to differentiate a product of functions. So u and v are functions from x, and so u prime multiplied by v plus u by v prime. And uh, so derivative of the fraction of function looks like this. Here is a formula of composite derivative of composite function. So we first of all we differentiate f by u. So we f that depends on u. Then u is differentiated by x. Here is the formula of derivative of the inverse function and derivative of parametric function. Any questions for now? Okay, no questions. And by the way, table of derivatives can be found not here. So in this section with practical lessons. So here is the table of derivatives. Anytime you can look into it. Okay. So let's start calculating derivatives of given functions that are given explicitly. So we will use table of derivatives and some uh, some arithmetical properties. So let's solve A. So for A, B, and D, we need to find first and second derivative. Yeah. So y prime equals power function. So let me remind you how to differentiate it. So the derivative looks like this. So we multiply by the exponent, and the exponent decreases. And pay attention, so that we multiply by u prime. It means that can be a composite function. So what are we doing here? So don't forget about the coefficient. So 3 by 2 and by x minus 5. So we just multiplied by 1, and the exponent became 0. And constant just became 0. And now we need also to calculate the second derivative. So we just differentiate the first derivative. We just do like this. So we differentiate this expression. And it just equals 6. Any questions about this part?
No questions.
Okay, no questions. And now let's continue solving. Let's move to B. We have the following expression. So we need to differentiate a product of functions. Of course, we can expand brackets, but now let's differentiate product. It will be so it will be easier. Mhm. Signs. And if we want to differentiate, let's write like this. Okay, so first of all, we differentiate the first multiplier. Of course, we can change the order because this operation is commutative in this case. So writing everything in details. And how will it look like? So for the first addend, so the first expression, so the derivative of this expression, 2x minus 3, and multiplied by this expression, plus this expression multiplied by the following, 2x minus 2x plus 2. Okay, and now I suggest you to expand brackets because it will be easier to differentiate, easier to find the second derivative. So expanding the first expression, 2x cube plus 4x square minus 2x minus 3x square minus 6x plus 3. So everything is correct. And the second expression. So 2x power of 3 plus 2x in power of 2 minus 6x power of 2 minus 6x by the way plus 6x and plus 6. So it should be correct. Okay, some of these multipliers can be cancelled. We can simplify it. And let's start simplifying. So eliminating this. And maybe that's all that can be eliminated. So for the greatest degree. So for x in power of 3, then let we just remove it. So then power of 2. So 4, 2, and 6. So removed it, cancelled. And just 3x in power of 2 remains. Removing it as well. Minus 8x plus 9. And that's it. So the simplified expression. And now we need to calculate also the second derivative. So differentiate this expression. So it will be 12x squared minus 6x minus 8. And let we check. Yeah, basically everything is correct. So that's it. Any questions about this task?
It says that it is 8x squared, not 12.
Yeah, stop. We multiply by 3. Yeah, maybe mistake here. Let me double check. It is mistake here. And here it's correctly. Okay, let me correct it for now a little bit. So, okay, so doing like this for now. Thank you for your attention. Really, you help me to improve materials. So, any questions? So, more questions, or that's it about part B? No questions, right? Okay, let's continue. So now part C, and for C we just need to find the first derivative, and as we can see, really it's a large expression. So finding the first derivative is not a very convenient task. So 1 plus x in power of 2 divided by 1 plus x, and everything in power of 5. Mhm. Uh, so, okay. This is a composition of functions. So composition of power function and a rational fraction. So we need to differentiate it like a composition of functions. So first of all, we are finding a derivative of the uh, outer function, so зовнішня. So 5 by this expression in power of 4, and then we multiply by the uh, uh, derivative of this fraction. So now we differentiate fraction. Just a moment, I will come back in a minute. Okay, I'm here. Okay, let's continue. So now we differentiate this fraction with using this formula. So first of all, what we write already, so the square of denominator, and then so if we can say uh, in this way, so we can forget about it for some time. And now differentiating, so now writing the numerator. So
But
u
probably x
equal
in the power of 2 in denominator.
uh, yes. So but yeah, I know, I guess I understand what do you mean, but for now let we do it in details. So u equals this, and v equals 1 plus x. So let me not skip these steps, because it will be so, just not to miss anything. Okay, so u prime equals to x, and we multiply by 1 plus x. And subtracting, so 1 plus x in power of 2, and uh, v prime equals 1. And now we are expanding brackets. So 2x in power of 2 plus 2x. And minus 1 minus x in power of 2. So, yeah, it will be x minus, so x minus 1 and plus 2x. By the way, something is, yeah, missing something. Yeah, you had a comment about it.
No, I mistake. I confuse.
Yeah, so, okay. So here is the function that we have. Basically, we don't have to expand all these expressions, so we don't have such requirements. So we can leave it in this form. Any questions maybe about this task? Okay, no questions, so let's move to the next part. So D. Again, this is a composition of composite function. So composition of power function and trigonometric function. So first of all, we differentiate cosine. No. First of all, we differentiate power of cosine. So 3 cosine over so cosine square over 4x plus oh no, multiplied. Stop. Going on. Yeah. So question.
So we multiply by minus sinus.
Yeah, multiplied by minus sine over 4x. And don't forget about this argument and multiplied by 4. Yeah, forgetting some hotkeys. So now let's multiply everything. So what do we have? Minus 12 cosine cosine square over 4x by sine over 4x. And I suggest you to simplify this expression, because we will have to find the second derivative, and we will have to differentiate this composite function. So we will have to differentiate product of composite functions, and it is not really convenient. So to avoid mistakes, let we transform this product of trigonometric functions into the sum. So it's more convenient to differentiate sum rather than product. So first of all, so we know that product of cosine of x by sine of x, can be written as double argument formula. So minus 24 cosine of 4x by the sine of 8x. So just trigonometric formulas. And let me remember. Yeah, by the way, we can look here some trigonometric functions, function formulas. Oh no, something is not. Yeah, I had to divide. By the way, and then we can just modify it like a. So we can transform it to the sum, to the sum. So sine of 12x plus sine of 4x, and it will be easier to differentiate. So
You forgot x between 12.
Thank you for your attention. And we will differentiate this expression, so it's more pleasant to differentiate some, definitely. So minus 3, 12 cosines of x, of 12x, and plus 4 cosine over 4x. And we also can move 4 out of brackets, like a common multiplier. So minus 12, 3 cosine over 12x, plus cosine over 4x. And that's it. Any questions about this task?
X between.
Yeah. Yes, I type so fast so that I forget about it sometimes. Okay. More questions?
No.
Okay, and now moving to the next part. So part E. In part E, we need to find the first derivative only. So 1 plus sine square of x, and this expression in power of 4. So again, this is a composite function. So first of all, we differentiate this power, and it will be equal 4. So this expression in power of 3 and multiplied by the derivative of this expression. And again, here we also have a composite function. So what do we have? So so it will be 0 plus 2 sine of x, and then we multiply by the derivative of sine, so by a cosine of x. And basically the result will be the next. So we can even transform it to the double argument, so just by sine over 2x. And that's it. Any questions? Okay, no questions. And now part F. Here we have such not a convenient expression, of course, but it wouldn't be interesting if it would be just a polynomial, for example. So here we have our combination of rational and irrational functions. And now let's start differentiating. So we'll differentiate this function as a product. So 2x multiplied by this plus x in power of 2 multiplied by the derivative of this function. And this function will be differentiated just like a power function. So yeah, it is also the a composite function. So 3, yeah, 3 multiplied by damn it, multiplied by -7, and also it must be multiplied by this expression 8x minus 5 prime. And let's continue calculation. So 2x here remaining without changes, and multiplying by this expression. So this is the power of 1/3. So it will be multiplied by 2/3. Minus 2/3, by the way. Stop. No, it will be multiplied by 1/3, and the power will become 2/3. So x square in the numerator, and this expression will be in the denominator, but don't forget the power. So in power of 2. And what about this expression? So the derivative of this expression will be equal to 8. So 3 by -7 minus 21, and minus 21 by yeah, forgot about to decrease power here, and nobody told me. So 20 minus 21 by 8 minus 168. Basically, that's it. We also can find a common denominator, but for now it would be a waste of time. But here it is found. Something can be incorrect here. Yeah, let me recalculate this. Yeah, if mod 8 by 21 is 168, yeah, incorrect. Okay, maybe any questions about this task? Okay, no questions. So continue with the calculating derivatives. So the last one example is G in task 1. So we will just find the first order derivative, and here is the product of composite functions. So composition of exponential and trigonometric function, and composition of arctangents and power function. So first of all, we differentiate it like a product. So writing everything in details. So doing like this. And now we differentiate these compositions. So, a derivative of this function. So first of all, so how to differentiate the exponential function? So 4 in the power of minus sine of x multiplied by logarithm of 4. And now we need to differentiate minus sine of x. And the minus sign, the derivative of minus sine is minus cosine. And don't lose also this arctangents. Plus this function multiplied, let me continue on the next line. This function multiplied by the derivative of square of arctangents. So the derivative of the power function, so 2 arctangents over 3x, and multiplying and then by derivative of arctangents. So the derivative of arctangents is the next. Just let me remind. So 1 plus u in power of 2. So u is 3x, so 1 plus 9x in power of 2. And again, we need to multiply by u prime. So multiply by 3. So basically, the derivative is found, but let we simplify it a little bit. So how can we simplify? We can move the common multiplier out of brackets. What can we move? We can move 4 in power of sine x, and also we can move arctangents of 3x. So let's do it. And now we will have expression in brackets. So what remains here? Logarithm of 4 minus logarithm of 4 multiplied by, okay, let me simplify it in another way. Minus logarithm of 4 multiplied by cosine of x and by arctangents over 3x plus plus 6, so 2 and 3 here, plus 6 divided by 1 plus 9x in power of 2. So simplified. Any questions about this task? So it looks more beautiful.
No.
Okay, no questions. Good. Okay. What also? So the next task is to basically the same. Okay. So the next task we have the function, and we need to find to calculate values at some points and derivatives of this function at some points. So now what we differentiate it. So again, differentiating the fraction. Yeah, of course we can expand brackets and just differentiate like a sum of fractions. Why not? We also can do it, by the way. So t in power of 2 minus 5t minus 1 divided by t in power of 3. Yeah, and so now what we expand it just to compare results and how it will look like. So 1 by t minus 5 by t in power of 2 minus 1 divided by t cube. And now let's differentiate it. So just sum of power functions. So the first one will be minus 1 divided by p square. The next. So here power is minus 2. So plus 10 divided by t in power of 3. And plus, so plus, so minus 1 by minus 3, so plus 3 divided by t in the power of 4. So derivative is found. And now let's calculate the function derivative values. So f from minus 1 equals, so what does it equal? Let's substitute. So minus 1, here 1, and here will be minus 1. So minus 1 plus 1. So these expressions will be cancelled, and it will just equal minus 5. Now f prime from minus 1, what will it equal? So here just 1, minus 1, and 1. Minus 1, minus 1, minus 10, minus 11 plus 3, minus 8. So minus 8 and f prime from 2. So 4, 8, and 16. Let me skip calculation all these fractions, or let's just believe everything that is written here. So minus 5, minus 8. Let's believe that here everything is correct. Any questions about this task?
No questions.
Okay, no questions. So let we continue. So moving to the task 3, and now we will find the derivatives of functions with usage of logarithmic differentiation. So let me remind you, why do we need logarithmic differentiation? So basically we have the next function. So x in power of 2 plus 1 and in power over sine of x. How to differentiate it? Either a power function or exponential function. It's not clear. So how to solve? So first of all, let's find logarithms of both parts. A logarithm of y equals a logarithm over this expression. And then we can move a sine of x out of brackets. So we just have this so product of these functions. So sine of x multiplied by logarithm of this function. And now we differentiate both parts. So the derivative of the logarithm. Let me remind you. So the derivative of logarithm is 1 divided by u and multiplied by u prime. So 1 by y and multiplied by y prime. So it's important, don't forget about it. And now let's calculate this derivative. Yeah, let me write it more. So in details. So cosine of x multiplied by this logarithm plus sine of x multiplied by derivative of this logarithm. So x in power of 2 plus 1, and also we need to multiply by the derivative of this expression. So 2x. But so we found the derivative, so such derivative, and that's not a final answer. Don't forget to multiply then both sides by the function y. So y prime equals, so we can just do like this. Multiply y by this expression. And we can just leave this like this. So like the final answer. Any questions about this task? Okay, as I see, no questions. So now moving to the part B. So logarithmic differentiation is useful not only for power exponential functions, but also for products of functions. There were a lot of functions that products and fractions of functions. It can simplify calculations. So let's do the next. So again, we calculate, so we take logarithms of both parts. X minus 2 in power of 2 multiplied by the root of the third, cube root, and also divided by this fraction. So it would be a nightmare just to differentiate like in a regular way, differенциювання в лоб. But we won't do it. So now now just remember some properties of logarithms. So this expression will be transformed to the sum of logarithms. So how will it look like? So logarithm of this expression plus logarithm of this expression plus logarithm of this expression. Oh, minus, by the way, minus. So if we divide logarithm, so logarithm of fraction equals difference of logarithm. And we can even simplify more this expression, just moving exponents out of logarithm. So here 1/3. minus 3x minus 5. So we can see that calculations are becoming simpler. So we just need to differentiate these logarithms. So y prime divided by y equals 2 divided by x minus 2 plus 1 by 3x plus 1 and minus 3 by x minus 5. And the final answer, so don't forget to multiply it by y, because it will be a mistake if you forget. And multiply by this frightening expression. So it's simpler, isn't it? So just to differentiate like a polynomial, but a logarithmic polynomial. I guess you agree with it. Any questions about this task?
No questions.
Okay, no questions. So let's solve one more example. So task C. Again, we have a product of functions. And we can convert this, so we can transform this product into the sum with using logarithmic differentiation. So logarithm of y equals so logarithm of x in x cubed plus logarithm of e in power of x2, e in power of x squared plus a logarithm of sine 2x. Again, we can, so before differentiation, let's simplify as much as possible. So it becomes 3 logarithms of x. It will just be x squared. And yeah, it will remain without changes. So now differentiating. So the first addend 3 divided by x plus 2x and plus plus 2, so sine of 2x by cosine of 2x, and again we don't, so we mustn't miss 2. So this part. And now let's write the final answer. By the way, this, so cosine of 2x by sine of 2x is actually cotangents of 2x. And multiplied by this expression. So it would, so it is simpler than differentiate product of 3 functions, and one of them is a composite function. So it would be a real nightmare. Any questions about this task?
No questions.
Okay, so now what we have a break for 5 minutes, and then we will continue. Let's continue. So the next part, we need to find derivatives of function that is given implicitly. So what does it mean that just given like equation, but y is not written in the explicit way. So we know that y is a function that depends on x, and that's just what we know. So who remembers how to find derivative of the implicit function? Your ideas, suggestions, how to find it? Okay, let me remind you. So we just need to differentiate both parts of this equation. And so the right part of the equation is 0, so the derivative of 0 is definitely 0. So now differentiating sign of x and y. So it will be cosine over xy multiplied by multiplied by xy prime. Xy prime, so by derivative of this product. Minus cosine over minus sine. Yeah, because so derivative of the cosine is minus sine. So minus sine of xy and multiplied by this product as well. And it equals 0. So we can move sum of cosine and sine out of brackets. It will be more convenient for us. And then just calmly differentiate this product. So derivative of x is 1, so y plus xy prime. So we remember that y is the function of a function that depends on x, so y prime. Okay, and now what do we have to do? What we have to do? We just need to solve the equation, solve this equation with respect to y. So now let's expand brackets. So y multiplied by this expression plus xy prime multiplied by this expression and equals 0. So now let's move this to the right part. So y, so this moving to the right, and now we need to solve it with respect of y. So dividing first of all both parts by this expression, and we will receive xy prime equals minus y. And finally, y prime equals minus y by x. So any questions about this task?
How we get in first row y plus x plus y prime?
Which
Yes.
row? This?
No, fourth, четвертый.
Fourth, okay. This, right? So we differentiate this sum. Oh, well, not sum, but product. And the formula of derivative of the product is the next. So we first differentiate. So we differentiate the first function, and then this. So derivative of first function multiplied by second function and plus first function multiplied by the derivative of the second function. Have I answered your question, or it's not clear enough?
No, I understand. Thank you.
Okay. And now, any questions about more questions or no questions?
No questions.
Okay, if no questions, let's solve one more exercise. So B also, and then we will continue to the task 5. So xy plus logarithm of x plus y equals cosine of y. Again, we need to differentiate both parts of this equation. So left part prime equals right part prime. And now start differentiating. So again, this is a product of functions. So y plus x by y prime. So differentiated this product. Now we need to differentiate logarithm. So write an x plus y in the denominator, and now we differentiate the numerator. Oh no, we differentiate this expression, x plus y. So it will be equal 1 plus y prime. So done with the left part. Now moving to the right part. So firstly, differentiating the outer function cosine, and it will be minus sine of y and multiplied by y prime. And now again, doing the same that we did in the first part. So we need to solve this equation with respect to y. So now doing the next manipulations. Let me move this expression to the right part, to the left part, and just a moment. Sorry. Okay, continuing. So moved this expression to the left part, plus xy prime. Let we expand this expression as well. So like this. Just to extract one y prime. And by the way, what and plus y, and it equals 0. And now let's move everything that is not that not contain that everything that doesn't contain y prime will move to the right. So that's what remains on the left and what remains on the right. So this part. And now we need to find y. So moving y out of brackets. And now solving this equation with respect to y. Well, just not to waste time with different manipulations, finding common denominators, and so on, I will just do like this, multiplied by this expression in power of -1. And it is the solution. Any questions about this task?
Там, де третя знизу строчка, як Все, да. Там і строчка над нею, як це вийшло?
Ось це
Да.
розкрив дужки. От і все. Ну, ось це дорівнює ось цьому. Ну, така арифметика.
А, ви розбили, все, я зрозумів.
So, expanded brackets. So, more questions?
No sense.
Okay, if no questions, so C will be like your home task. Basically, it is solved, but try it in your own. It will be a good practice. But we need to solve other tasks. So we need to solve finding derivatives of a function that is given in a parametric form. So now what do we have, by the way? So parametric function is given in the next way: t plus sine of t, and y equals minus cosine of t. So this is basically a function. So y is a function that depends on x. And let me remind you a formula of derivative of the parametric function. So the first derivative is the following. So we differentiate y and x by t, and then we divide y prime by t, we divide by x prime by t. And here is the formula of the second derivative. First of all, now we need to find derivative of these functions by t. So 1 plus cosine of t. And y prime by t equals sine of t. And now we need to find derivative of y by function x. So basically, how can we write it? So so it is dx dy by dx, and if we expand it, so dy by dt divided by dx by dt. So just how do we receive this formula? That's just a reminder. So, and how does it look like? So sine of t divided by 1 plus cosine of t. And the first derivative is found. What about the second derivative? We need to differentiate y by t once more. So let's do it. By the way, we can also use t square here as so instead of t by t, but just for your information. So the derivative is cosine of t. And next, so we basically have everything for the second derivative. Let's write it. Mistake here. So prime, two primes basically. So cosine of t divided by 1 plus cosine of t in power of 2. Let me quickly check how can we if we can modify it. So if we can reduce it, let's try, by the way. So 1 plus 2 cosine of t plus cosine of so square cosine of t. Well, I guess that there is no chance uh, to reduce somehow. Yeah, we can. So I don't remember so this formula, if we can we modify it, but let we remain without changes. Let we leave without changes it. This is basically the final answer. Any questions about this task? Okay, and now let we just for interest, let we build a parametric graph of this function. I don't remember how to. Okay, Desmos parametric. Cut off a little bit. So let me continue sharing my screen. So just checking how. So really not understandable curve. But okay, so let's live with this. Oh, but we can 2p, for example. This is a periodical function. I don't remember the curve basically, but yeah, this is a real curve. Interesting. Okay, let's continue. What else do we have? Well, so derivatives of the first and the second. Oh, yeah. Let's find differentials of the first and the second order. So basically, how how can we also write derivative of the function? So basically the formula is the next. So dy divided by dx. So the differential of functions looks like this: y prime multiplied by dx. Well, let me move it to the bottom, and we will calculate so first the derivatives and then differentials. Tangent square of x so it equals 2 tangents of x and multiplied by 1 over cosine square x. Okay. Yeah, and let's simplify. So what we write it like a fraction. And last argument of cosine, that that is not good. So now calculating the second derivative. Okay, and now differentiating this fraction. So 2. Okay, let me move 2 out of brackets as well. So 2 tangents of x. No. So cosine of square x, by the way, divided by cosine of square x. So it will be cancelled. Great. Plus tangents of x. Stop. Minus tangents of x multiplied by derivative of this function. Minus tangents of x multiplied by 2 cosine of x and minus sine of x. And now let's simplify it. Everything. So it will be 1 plus 2. And by the way, let we just write as an argument over to sine, like a double argument. Why not? We can do it. So that's it. So derivatives found, and now let's find differentials. So dy equals, so we just multiply the derivative by dx. And the second differential basically equals so y prime twice by dx in power of 2. Basically, it means like square of the whole dx, but usually it's not written in brackets. So how it looks? Just by dx2, by dx in power of 2. And that's a solution. Any questions about this task? Okay, as I see, no questions. Okay, let's solve one more exercise that is similar to it, and then we will use the differentials on practice. So how are they useful? So 2x by sine of x plus this expression multiplied by cosine of x. And now let's calculate the second derivative. Yeah, we cannot simplify it, unfortunately, because we have different coefficients before. So we have different degrees of multipliers before sine and cosine, so it won't be so simple. So we will just have to differentiate products. So 2 sine of x plus 2x multiplied by cosine of x. And plus 2x multiplied by cosine of x. By the way, this expression will be a little bit simpler. And minus this expression multiplied by sine of x. And let we simplify a little bit. So 2 sine of x plus 4x multiplied by cosine of x minus this product. Okay, I can move sine out of brackets. Maybe it will be a little bit simpler. Why not? Let me try. So 4x multiplied by cosine of x plus 2. So 2 minus x minus 1. So plus 1 minus x in power of 2 multiplied by sine of x. Basically, that's what can we simplify. And we can't simplify anything more. Okay, now let's find differentials. So the first differential just like this. So we multiply this expression by dx. So, and the second differential, so attentively, that for y we write like this. So d2y by dx square. So how to write, for example, the second derivative. So d2y by dx square. So like this. So multiplying this expression by dx in power of 2. And that's it. Any questions about this task? Okay, no questions. So now let's solve tasks with practical usage of differentials. We will calculate some values. So for A, we need to calculate arctangents 1.04. So we need to calculate it approximately. So let's define the following function, arctangents x. So x equals 1 and delta x. So we just we use the definition of a differential and derivative. So delta x is 0.04. Then we will use the next formula. So f from x plus delta x approximately equals f from x plus f from f prime x multiplied by delta x. So this formula will be used. It will be useful for us, so let we not erase it for now. So arctangents of 1. First of all, let's differentiate arctangents. Basically, it equals 1 divided by 1 plus x in power of 2. So this is the derivative of arctangents. So f from 1 equals, so this is arctangents of 1, and it equals p by 4. And derivative is the following. So 1 second. Okay, and now let's calculate the arctangents of 104, 1.04. So p by 4 plus 1 second multiplied by 0.04. And what we will receive, so let's calculate it. So yeah, of course, p by 4 will be calculated only approximately. And arctangents of 104 is the next. So the difference is in the fourth sign, so fourth position. So quite good precision. Any questions about this task?
No questions.
Okay, let's calculate one more example. So root of the first power of 17. So let's calculate it as well. So that's not a transcendent value that that is more understandable for us. So root of the fourth power of 17. So which value will we use for x? Your suggestions. What will be equal x? What will be equal delta x? So the root of power 4. Daniel, yeah, your suggestion?
I think x equals to square root in 4th power, and under square root 16.
Yeah, so x equals 16 and delta x equals 1. So
Yes.
yeah, so yeah, x is basically the argument under, so not square root, but root of power 4. Okay, and now calculating the derivative. Yeah, by the way, f from x equals this expression, yeah, root of fourth power. Okay, now differentiating. So this is power 1 by 4. So x in power of 3 in power of minus 3/4. And if we rewrite, so 1, 4, and x cubed under the root. So that's what we have. Okay. So now calculating this value. So square root of 17 approximately equals f from 16 plus f prime from 16 by by 1. So calculating. Okay, let me expand it. Let me maximize. Plus this expression, so 16. And basically 1, just we will skip it. So this expression equals 2. And here what we have, 1 plus 1 over 4. And what we basically have, so yeah, 4 multiplied by 4 multiplied by 2 in power of 3. So what we have, so 2 plus 1 multiplied by 32, and it will be equal if not approximately, so 2 plus 1 over 32. So which result do we have? And 17 in power of 3 1 over 4 equals the next value. So here is the precision. So difference after the third sign, after the third position. So any questions about this task?
No questions.
Questions about this lesson, previous lessons, our other questions? Okay, if no questions, so have a nice day. Stay safe. Thank you for your attention. Goodbye.
Thank you. Goodbye.
Thank you. Goodbye.
Nice days for you too. Goodbye.
Goodbye.